I want to teach you my secret to know how to convert from galvanometer to ammeter or voltmeter. If you are writing 2025 JAMB exam, come to the front seat and listen to me. Okay, so galvanometer I can either convert it to an ammeter, or I can convert galvanometer to a what? A voltmeter. That is, they can function to measure current, or they can function to measure what? The voltage. Okay, now because me, I'm not really smart like that, so I just used to know that, okay, if I'm converting galvanometer to ammeter, I need to do what we call GALSP or GALSP, GALSP. Now, GALSP means something. It's not just English. It means that if I want to convert galvanometer to ammeter, I need a what? A low resistance resistor. Now, that resistor that we need is what we call shunt. Shunt. Now, and that shunt must be connected in P, which means what? Parallel. So if I know this, I know the other one. So GASP means low galvanometer to ammeter, low resistance, abi. Now, and that resistance shunt, don't forget, this shunt is a resistor, but that resistor must be of low resistance. That's what it means. Then what? The connection must be what? In parallel. Now, if I want to convert galvanometer to voltmeter, because I already know this one, so it's this one that I cram. I don't need to know this one. So I just need to, now if I'm converting galvanometer to voltmeter, I need, if this is low, this one must be high resistance, abi. But the resistor we are going to use, because it must be high, that resistor must be a multiplier. Then, because this one is already connected in parallel, this one must be connected, and because it's also high, it must be connected in what? In series. That is all. I don't need. So in the next video, I'll be teaching you how to calculate them. This is just concepts, because this one is a JAMB question in physics. So how to convert galvanometer to ammeter, galvanometer to voltmeter. So you just know GASP, like you're gasping for a ball. L is not just gasp like this, but it must be L, GASP, LSP. Okay, so that's the way to know this. So low resistance shunt in parallel, high resistance multiplier in series. It must be high. So if you are high, you must multiply, and if you want to multiply, it must be in series. Just a way to know it, you understand? If you have not joined our class, see the way I'm sweating, join our class. If you have not liked this video, yeah, do that now. If you have not shared it to your friends to help them, yeah, do that now. What again? If you have not comment, okay, should I tell you? Okay, let me give you this question. Okay, multiplier. Okay, if they are connected in parallel, okay, what must be the current? Will the current be the same? Okay, no, don't let me give you that question. I've taught you this one though. It's in one of the videos. If they are in series, what happens to the current? Yes. Is the current in this going to be the same as the one in this? Just drop yes or no. With the current, if these resistors, they are connected in series, okay, if this multiplier is connected in series, will the current be the same? Yes or no? I already taught you this, but I'm just asking you. So if they are connected in series, will the current be the same? Yes or no? If it is yes, just drop yes, it will be the same. If the current will differ, just say no. Understand? So okay, so see you in the next video. Bye for now. Yeah, bye. Join our class if you have not joined. I'm teaching everything, all these chemistry things. We'll teach you. Bye for now. See you in the next video.